Hello and thanks for joining me. Well, here lately I've been really involved in restoring machinery, modifying machinery, upgrading machinery, and I've had a few comments like, what do you ever make in your shop? You know, what do you do with your machines? And that's a valid question. I assure you I stay fairly busy, although lately most of my time has been consumed with restoring machinery. But on several occasions I make things for other people quite often. I've got about 3 projects lined up right now, and I thought I'd get a couple of those knocked out. I'll show you what we're going to do today. Okay, I got a friend with a Tiffany lamp, and it's stained glass. It's fairly elaborate, and it's got, like, I don't have the stained glass lampshade, but this is what goes in the hole on the top of the lampshade. And it goes in from the top, and it apparently soldered. But somebody has tried to resolder it several times, and it keeps on breaking. So I got a plan on this. And what I'm going to do is build a washer kind of like this. This is from some plastic plumbing. I'll make it out of steel that fits inside that. And I'm going to thread this outside and thread this inside. So right now, the first thing we're going to do is clean this area up right here, clean that solder off of there. And then this is slightly tapered in here. I'm going to bore it straight with a boring bar in the lathe. Thread the inside of that, then make a washer like this and thread the outside of this, because there has to be a clearance in here. There's a piece that goes up inside that, the electrical connections. So that's what we're going to do today. And here's some other projects that I got. This right here is I think from a David Bradley play track. And the motor has, this is a drive pulley, and I don't know what the difference is, but they need a pulley that's stacked like that. This is drives a big flat belt, and obviously that's a flat belt too, so I don't know what drives what. Maybe there's a power takeoff on it. Looks pretty heavy for a play tractor, toy tractor. But we got to drill those 3 holes right there and put bolts on there to bolt it together. So that's another project. And this project here, I've been putting it off. It won't be done in this video. It'll be done in a future video. But this is, some of you may remember me making these. I made a video on that. And that's a ratchet mechanism for a wheel, for a play track, toy tractor. This mounts right there. Well, what I'm going to do is I'm going to weld them together like that. Bore that out so that slips inside. And then I'm going to let somebody else tack weld that to that. But this wheel is driven by a hub that's pinned to this axle. And this takes the place of a differential. In other words, it lets one rear wheel go faster in a turn. But this is what drives the wheel. And I made some hubs that go on this earlier. I'll see if I can find a picture and post it on this video that mesh with that. And I hope it all comes together for them. It's been a big job altogether. But I'm apprehensive about drilling that wheel. That's just sheet metal. It's got a kind of a rolled in section there. And after I bore it out bigger, it's just going to be a raw edge of sheet metal. But this will go all the way through it. And that'll be welded to that. And I think it'll be strong enough, but I'll be honest with you, it has me worried. But these match the original play track wheel, although this bore is smaller. So anyway, that's the 3rd project. Anyway, we're going to work on this Tiffany lamp today. So let's get started. I haven't got a 3-jaw that's big enough to hold that. If I flip the jaws over, there is, but then it hits the steps on the jaws, this part does. So I've got to use it like, or clamp it like this. And there's little grooves in this four-jaw chuck that can hold it. And I'm going to clean out this, I hope. I think that might be it. Kind of thinking I might need to run this in back gear, get it really good and slow. Really what I'm doing here is taking out the old solder. A little bit nerve-wracking. It looks like it's doing good. Probably got to work. That relief right there is for the inside. I'm going to use this tool to cut right there, but I'm also going to use it to clean up right there. But that relief had to be there for that curve. I guess you could call that trepanning. I believe that's clean enough to cut threads in. I don't want to go too thin. I don't know in this depth right here, although it looks plenty thick. It looks plenty thick. Well, this wall right here is kind of thin. I'm going to cut threads in it, and I want to be able to thread into it. So let's maybe go one more pass. Just don't want to go too thin right there. These are going to be no certain thread. They're just going to be 20 threads per inch, and I'm just going to cut them to fit. I think I'm going to make it 20 threads per inch. That looks appropriately fine. You go too fine and it gets weak and gets real critical. The thread strength declines a little bit. So we're going to go with 20 threads per inch. And I'm not going to cut a relief in the back to end my threads. I'm just going to let them end themselves, and it'll cut a little relief in there. Here's the thread insert I'm using. It's 11 IR AG60, I think. Okay, let's see. 20 threads per inch. Right there. "20 threads per inch" is left, and then out. That's this right here, and it's already in the out position, I think. Okay, for internal threads, this compound has to be set to the other side. There's 29.5 right there. Okay, those threads look sharp, which indicates to me that they're a full thread. So we're done with that. And what we need to do there is run some sandpaper over those threads. It knocks the very top edge of the threads off, which usually has a burr. It'll make you think you got tight threads when in reality it's just those burrs creating a problem. That deal. Okay, we're done with that piece. Now we got to create the piece that goes inside that. Just going to use these bars to square up that piece right there in the chuck. Okay, now I got to establish the external diameter of that and turn it down so that I can thread the outside of that that'll fit into that. Now the thread depth for a 20 threads per inch is about 49 thousandths. So 49 times 2 is 98 thousandths. So I've got to add 98 thousandths onto this diameter right here. 1.978. Okay, I need to take off 210 thousandths. At least according to my calculations. Needs to be 1.978. 1.778. Okay, I need to cut 107. I forgot to divide in half. Can't believe I did that. 107. What about 2.5 thousandths a pass? I don't think that's deep enough. I'm going to try. Nowhere near. I probably didn't get that quite small enough in diameter. We'll just keep cutting threads until it fits. Well, let's start it on there. I think I'm going to go one more pass and then take some emery cloth to it and try that. Okay, now we got to bore the center of that. Ooh, that might be kind of a big cut. I got it clamped fairly tight in the chuck, but I still don't want to take a chance on thing popping out of there. Take about 10 thousandths at a time. think I'm going to take this thing out and turn it over. I'm afraid it's going to take too big a bite and jerk that thing out of the chuck again. Well, I don't really know what that thickness there needs to be. If the lampshade is too thin, I may have to make this washer go over the top of that brass. Right now it goes over the top of that, no problem. But I got a feeling when this is all put together, that may be adequate. Well, what do you think, Jerry?
I think it's great. I mean, that was a dilemma.
Yeah, get rid of that extra solder on there, and
Yeah.
I think it'll look good.
No, it's excellent.
Good deal. Okay, on to this next project. This friend of mine wants that bolted on right there. And this is a larger bore than that, but he said this goes onto the motor and the motor shaft is flush with the end. So that doesn't really matter as long as there's enough metal there. It's only slightly larger. Anyway, I don't know if 1/4-20, that's what those are. I don't know if that's adequate to hold that or not, but that's what he wants, so that's what we're going to give him. I'll put hardened bolts in there, socket head Allens. The first thing we got to do is face that off because we don't want this to wobble once it's bolted on there. Okay, I've got a 1-inch shaft, bar, whatever, mounted in my chuck, and we're going to use it as a mandrel. So we're just going to take off a little bit here, just enough to make sure it's accurate, good and flat. This looks like a fairly well machined surface. I think I'm going to take a little emery cloth to that to clean it up. Put the other jaws in. Not perfect, but probably good enough. That looks a little better. I'm going to mount this back in there. Well, I'll show you. I'm going to use my tool post drill to locate those holes. Wow, it looks like that pulley's got a crack in it. Anyway, what we're going to do is put the tool post drill on there and locate these holes with the tool post, and then put the other one back in and drill the holes, at least the start of the holes. I'll probably finish drilling them in the mill. So a pretty good fit in there. That's my center drill, or not my center drill, my spotting drill. I'm going to turn it around backwards just to locate those holes. It looks good. Now, my only concern is the cross slide moving. So I guess I will lock one gib adjustment, because I don't know of any other way to lock it. Okay, we got our bolt circle there, and I'm assuming that it is exactly divided into 3. But I'm going to put my indexing wheel on there and make sure. Some of you may have seen this before. My indexing wheel, I guess. Indexing gear. Indexing gear would be more appropriate. It's an expanding arbor. I've got this thing. This is an excellent way to index on a lathe. Right here I got red and black. Red I think is, let's see, 1, 2, 3, 4, 5, 6. Yeah, red is 3 and 6. And this is a 48 tooth gear. The black is divided into 4. Okay. Okay, we're lined up perfect there. Turn it to the next third. Lined up perfect. Turn it to the next third. Again, lined up perfect. Hallelujah. Okay, now I'm going to turn this spotting drill over that I was using for an alignment pin, and then remove this pulley and install the other one. Set screw there. I don't think it'll be used, but I want to avoid it anyway. Okay, now I'm just going to spot drill these holes and then take it over to the drill press and finish drilling them through. And this section in here, that's pretty dang deep. It's about that deep right there. But trying to drill that deep with this tool post drill is a little extreme. Although that is pretty soft. Cast iron, I guess. There we go. Now we're ready to take that out and drill it in the drill press. Okay, I'm drilling from the side that it's mounting to, because if there's any misalignment in my drill press, or if the drill wanders a little bit, it'll still bolt on there. The bolts might flex a little bit, but it'll be really close and not a problem. Okay, there's one hole. Lock everything down. Cast iron drill's pretty easy. That's a deep hole. One down, two to go. I've actually got some bolts long enough. They're not the right kind of bolts. They really need to be high strength bolts. I think I need to run a tap down those holes. They got paint, plus I surfaced it. So it's probably got a burr in there. Let's do that. Run a tap down there. Oh, that looks like it's lined up perfect. Yeah, very slightly off. Okay, I drilled these holes out to 1/64 over a quarter. Okay, here we go. Oh, heck yeah. Looks perfect to me. Well, that about wraps it up for today. Join me next week. Maybe we'll work on those wheels, and then we'll get started on that hardened lathe. Anyway, thanks for joining me. Be sure and subscribe and ring that bell.